All right, so let's see this one. So we're gonna have to consider what it our u is. So this problem very obvious. I'm gonna let u to be something inside a parenthesis. So I'm gonna let u equal x cubed minus 3. Now after letting u, we're gonna take derivative. So du will be equal 3x squared dx. And that is this 3x squared dx is the du. So when we put that back into our integral, we're going to have u squared, and then 3x squared dx will be du. And again, this is going to be the power rule. We're going to take the integral by increase the power to u to the power 2 plus 1 will be 3 over 3 per c. And we don't left our answer like this. We're going to have to replace by x cubed minus 3 to the power 3 over 3 per c. That's going to be the antiderivative of this function. Now let's take a look at this one. Okay, so this one it doesn't have a parenthesis. So how do I know what is my my u gonna be? Okay, but you see outside the radical there's an x, and inside the radical I have x squared minus 5. If I take the derivative of x squared minus 5, I will get 2x, which is the variable outside of the radical, right? So we're gonna let u equal to x squared minus 5. So now we're gonna have the derivative of u will be du. We take the derivative both sides, so du equal 2x dx. Okay, so we have our du is 2x dx. However, our expression is only need x dx. So we have an extra 2 right here. Can we divide both sides by 2 in order to get x dx? Yes, we can divide both sides by 2, right? And then we're going to have 1/2 du will equal to x dx. So the x dx here will be replaced by 1/2 du. For our integral will be square root of u times x dx will become 1/2 du. Okay, because 1/2 is a coefficient, so you can feel free to bring it to the front or leave it like that. We're going to have 1/2 u to the power 1/2 du. So by taking the integral of the power rule, we're going to have 1/2 u to the power 1/2 plus 1 over 1/2 plus 1. And then that will give you 1/2 times u to the power 3/2. It means you're going to multiply 2/3 and then plus c. And we will have 1/3, since we can cancel out the 2. So 1/3 u to the power 3/2. So u will be x squared minus 5. So I can do x squared minus 5 to the power 3/2 per c. Okay, so that is the integral. And how about where you have the integral that involve trigonometry? So recall for the trigonometry with the power, you can always write at cosine t to the power 3 sine t dt. And when you rewrite like this, you will obviously see that the function inside the parenthesis is cosine t. So I'm gonna let u equal to cosine t. Then our du, the derivative of cosine, what the derivative of cosine? Derivative of sine is cosine, derivative of cosine is negative sine. So we're gonna have negative sine t dt. Okay, but we only need sine t. We don't need negative sine t. So in order to make it sine t, we're going to multiply both sides by a negative. So we will have negative du equals sine t dt. Okay, so sine t dt is our negative du. So we're going to put that back in here. We will have u to the power 3 times negative du. Right, so this will give you, so don't put the expression like this because it's gonna be easy to make you confused that you're gonna take u to the power 3 minus du. So I would suggest to bring the negative to the front of the u cube. So you have negative u to the power 3 du. And apply the power rule, we have negative u to the power 4 over 4 plus c. And our u in this case is cosine, so you have negative cosine to the power 4 over 4 plus c. So that is how you use u-substitution.